Welcome to the at an another exciting module of intuitive DevOps for you course. That's the fourth module. It's all about DevOps and IAC. And now we are going to deal with the first part of fourth module, that is DevOps culture and practices. So I think we have been hearing this word recently a lot. DevOps, 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 everywhere DevOps. If you open the YouTube, DevOps. If you open the Facebook, DevOps. Insta, DevOps. Everywhere DevOps. All about DevOps. What is DevOps? Astonishingly, DevOps is a term that we hear more and more in enterprises with phrases such as "we do DevOps" or "yes, we use DevOps tools." Basically, the DevOps is the counteraction of the words development and operations. So, DevOps is a culture different from traditional corporate cultures and requires a change in mindset, processes, and tools. It's often associated with continuous integration and continuous delivery practices, fundamentally, which all are software engineering practices, but also with the infrastructure as code, that's IAC, which consists of codifying the structure and configuration of infrastructure. So in this module, we will in this part of the module we will see what DevOps culture is, what DevOps principles are, and benefits of it bringing to your company. Then we will look into CI/CD practices, and we'll understand IAC, and finally we will detail IAC with its patterns and practices. So in this chapter, broadly, we will cover understanding DevOps, implementing CI/CD, and continuous deployment, and we'll understand the IAC, infrastructure as code. So now let's begin with uh, getting started with DevOps only. So the term DevOps was introduced in 2007 to 2009 by Patrick DeBois, Jeannie Kim, and John Willis, and it represents the combination of development dev and operations ops. It has given rise to a movement that advocates bringing developers and operations together within teams. This is to be able to deliver added business value to users more quickly and hence be more competitive in the market. DevOps culture is a set of practices that reduce the barriers between developers who wants to innovate and deliver faster on the one side, and on the other side operations who wants to guarantee the stability of production systems and the quality of the system changes they make. DevOps culture is also the extension of the agile processes such as Scrum, XP, and so on. So, which make it possible to reduce delivery times and already involved developers and business teams, but are often hindered because of the non inclusion of ops in the same teams. So the communication and this link between DevOps dev and ops does. So therefore, allow a better follow-up and to and production deployments and more frequent deployments of a better quality, saving money for the company. So the next question would be, what are the key elements of DevOps? So to facilitate this collaboration and improve communication between dev and ops. So there are several key elements in the processes to be put in place as in the following examples. So the first one is more frequent application deployments with the integration and continuous delivery. In short, we call it as CI/CD. The implementation and automation of unitary and integration tests with a process focused on behavior driven design. This is called BDD in short, or test driven design, or TDD. The implementation of a means of collecting feedback from users, and finally monitoring applications and infrastructure. So now let's look into the most important three axes that DevOps rely on. So the DevOps movement is based on three axes. The first one is the culture of collaboration. This is this is the very essence of DevOps. The fact that teams are no longer separated by silos, specialization. That's like one team of developers, one team of ops, one team of testers, and so on. It's like always the teams are separated by silos of specialization. So the very essence of DevOps is the fact that the teams are no longer separated by silos of specialization. But on the contrary, these people are brought together by making multidisciplinary teams that we have the same objective to deliver added value to the product as quick as possible. Then processes. So to expect a rapid deployment, these teams must follow development processes from agile methodologies with iterative phases that allow better functionality, quality, and rapid feedback. So these processes should not only be integrated into the development workflow with continuous integration, but also into the deployment workflow with continuous delivery and deployment. So the DevOps process is divided into several phases. The first one is the planning and prioritization of functionalities, and phase 2 development, phase 3 continuous integration and delivery, and phase 4 continuous deployment, and phase 5 is continuous monitoring. So when all phases happens, then basically it makes a collective DevOps process, so which improves the overall efficiency of operations as well as development teams. So then we have tools. The choice of the tools and products used by teams are very important in DevOps. Indeed, when teams were separated into dev and ops, each team used their specific tools, deployment tools for developers and infrastructure tools for ops, which further widened the communication gaps. So, with teams that bring development and operations together, and with this culture of unity, the tools used must be usable and exploitable by all members. Developers need to integrate with monitoring tools used by ops teams to detect performance problems as early as possible, and with security tools provided by ops to protect access to various resources. So, in a nutshell, this slide illustrates the three axes of DevOps culture. So the collaboration between dev and ops, the processes and use of tools. Then so we can go back to DevOps culture with Donovan Brown's definition. So, what he said is DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. So, the benefits of establishing a DevOps culture within an enterprise are as follows. The first benefit is better collaboration and communication in teams, which has a human and social impact within the company. So, shorter lead times to production, resulting in better performance and end user satisfaction. And second, reduced infrastructure costs with IAC, that's infrastructure as code. And third one, significant time saved with iterative cycles that reduce application errors, and automation tools that reduce manual tasks. So teams focus more on developing new functionality with added business value. We saw earlier that one of the key DevOps practice is the process of integration and continuous delivery, also called in short as CI/CD. So, in fact, behind the acronyms of CI/CD, there are three practices. The first one is continuous integration, CI. Second one is continuous delivery, CD. And last but not least, continuous deployment. So, what does each of these practices correspond to? What are their prerequisites and best practices? Are they applicable to all? Let's look in detail at each of these practices, starting with the continuous integration. Continuous integration. So, in the following definition, given by Martin Fowler, there are three key things mentioned: members of a team integrate and as quickly as possible. So, continuous integration is a software development practice where members of a team integrate their work frequently. So, each integration is verified by an automated build, including tests. So, to detect integration errors as quick as possible. So, that is CI, continuous integration, as Martin Fowler, as per his definition, the three key things that he has mentioned in his definition are: members of a team integrate and as quickly as possible. So, CI is an automatic process that allows you to check the completeness of an application's code every time a team member makes a change. So, this verification must be done as quickly as possible. So we see DevOps culture in CI very clearly with the spirit of collaboration and communication, because the execution of CI impacts all members in terms of work methodology, and therefore collaboration. Moreover, CI requires the implementation of processes such as branch, commit, pull, pull request, code review, and so on and so forth. So, with automation that is done with tools adapted to the whole team, such as Git, Jenkins, Azure DevOps, and so on and so forth. And finally, CI, continuous integration, must run quickly to collect feedback on code integration as soon as possible, and hence be able to deliver new features more quickly to users. So now let's look into implementation of CI, continuous integration pipeline. So to set up CI, it's therefore necessary to have a source code manager. So that you can see here on top of your screen. That will allow the centralization of code of all members. This code manager can be of any type: a Git, SVN, or Team Foundation source control. So it's also important to have an automatic build manager, that's CI server, a continuous integration server, or automation server that supports a continuous integration such as a Jenkins or GitLab CI, TeamCity, Azure Pipelines, GitHub Actions, Travis CI, Circle CI, and so on so forth. Here you can see this is our continuous integration or automation server. So widely used tools for automation is Jenkins, GitLab CI, and Azure Pipelines, and Circle CI. So each team a member will work on the application code daily, iteratively, and incrementally. Such like in obviously they follow agile methodology with some Scrum framework. They have to do iteratively and incrementally only. So each task on the feature must be partitioned from other developments with the use of branches. So regularly, even several times a day, members archive or commit their code, and preferably with the small commits that can be easily fixed in the event of an error. So this will therefore be integrated into rest of the code of the application with all of the other commits of the other members. So basically, if you see this guy is a Python guy, this guy is a front end guy, or maybe HTML, CSS, Java. So this guy developed one module, and this guy has written another module, and he pushed the code, and then he pushed the code, and other guy also will push the code, and he will also integrate back that code with him. So this integration of all the commits is the starting point of CI process, continuous integration process. So this process executed by the CI server. So this is our CI server. So we are going to use Jenkins only. So let's imagine that this CI server is a Jenkins server. So the CI server must be, so this process must be automated and triggered at each commit. So the server will retrieve the code and then do the following. So the first step is build the application package, so compilation, file transformation, and so on, and then perform unit tests with code coverage. So this CI process must be optimized as soon as possible so that it can run fast and developers can have quick feedback on the integration of their code. For example, code that is archived and does not compile or whose test execution fails can impact the block of the entire team. So sometimes a bad practice can result in the failure of tests in the CI, continuous integration. So deactivating the test execution, taking as arguments, it's not serious. So it's necessary to deliver quickly, or the code that compiles, it compiles, so it is essential. So on the contrary, this practice can have serious consequences when the errors detected by the tests are revealed in the production. So the time saved during CI will be lost on fixing errors with hot fixes and redeploying them quickly with the stress. So this is the opposite of DevOps culture, with poor application quality for end users and no real feedback. And instead of developing new features, we spend time correcting errors. So that is the reason feedback is very much important. So here in continuous integration, we will also have a feedback loop. If it is feedback about what are going well and what are not going well, fixes, hot fixes, bug fixes, everything, complete information will get back to the our developers. So with an optimized and complete CI process, the developer can quickly fix their problems and improve their code, or discuss it with the rest of the team and commit their code for a new integration. So this diagram which is on your screen shows the cyclical steps of continuous integration that include the code being pushed into the SCM, source control manager, or source code manager, so by the team members, and the execution of the build and test by the CI server. And the purpose of this fast process is to provide rapid feedback to members. We have just seen what is continuous integration is. So now let's look at continuous delivery practices. So continuous delivery. So once continuous integration has been successfully completed, the next step is to deploy the application automatically in one or more non production environments, which is called staging. This process is called continuous delivery. CD often starts with an application package prepared by continuous integration, which will be installed according to a list of automated tasks. These tasks can be of any type: unzip, stop and restart, service, copy files, replace configuration, and so on, so forth. The execution of functional and acceptance tests can also be performed during CD process, that is continuous integration process. Unlike CI, CD aims to test the entire application with all of its dependencies. So this is very visible in microservices applications composed of several services and APIs. So CI will only test the microservice under development, while once deployed in a staging environment, it will be possible to test and validate entire application as well as the APIs and microservices that is composed of. So in practice, today it's very common to link CI with the CD, that is continuous delivery, that's still staging. So in an integration environment, so that is CI, that is, so CI deploys at the same time in an environment. It's indeed necessary so that developers can have at each commit not only the execution of unit tests but also a verification of the application as a whole with the integration of the developments of the other team members. So now let's look into the implementation of CI, the implementation simulation of CD. Okay, the continuous delivery pipeline implementation. Of course, CI is also integrated into CD. Without CI, you cannot go to CD. So that's the reason as a CI and CD together. So continuous delivery. So it's very important that package generated during CI and that will be deployed during CD is the same one that will be installed on all environment. So this should be the case until production. However, there may be configuration file transformations that differ depending on the environment, but the application code binaries DLL and JAR, that's jar related to Java, DLL related to Windows execution files, it's Windows files and binaries, so must remain unchanged. So this immutable, unchangeable character of the code is the only guarantee that the application verified in an environment will be of same quality as the version deployed in the previous environment, and the same one that will be deployed in the next environment. If changes are to be made to the code following verification in one of the environments, once done, the modification will have to go through the CI and CD cycle again. So before we discuss the flow of the continuous delivery pipeline, let's look into continuous integration first. As usual, the developers have committed their codes, they have pushed their codes to the our source code, of course, as a source code manager or through the SCM, they have pushed to the GitHub, a source code a repository. Okay, from there, a CI server, a Jenkins server came into the action, and it took that binary, it took that source code, and it has built the application. Then it has done some tests, unit tests, and this kind of source code tests basically. After that, it has been packaged into an archive. We call it as an artifact. So your artifact or an archive is ready. So now it's time to enter into the continuous delivery. So the tools the tools setup for CI or CD, the continuous delivery, are often completed with other solutions. Which the most important tool, one of the tool is a package manager. A package manager. So here it is. Package manager. So this constitutes the storage space of the packages generated by CI. Yes, it is. The CI, as I have told you, of course, we don't need to, so this feedback is also there. But as I have told you before, at the end of the CI, it will generate an artifact. So that artifact should be pushed into the package manager. So this constitutes the storage. The package manager constitutes the storage space of the packages generated by continuous integration and recovered by continuous delivery. So these managers, the package managers, must support feeds, versioning, and different types of packages. So there are several on the market, such as Nexus, ProGet, Artifactory, and Azure Artifacts. So I like Nexus. I use Nexus, and we will be using Nexus in this course only. So then we have one more tool that's called Configuration Manager. So this allows you to manage configuration changes during CD. So most continuous delivery tools include a configuration mechanism with a system of variables. So in CD, the deployment of application in each staging environment is triggered as follows. So there are two options to get triggered. So one, it can be triggered automatically following a successful execution on previous environment. For example, we can imagine a case where the deployment in the production or sorry pre-production environment is automatically triggered when the integration tests have been successfully performed in a dedicated environment. It can be triggered manually for sensitive environments such as the production environments. So for production environment, obviously it's a manually triggered one. So following a manual approval by a person responsible for validating the proper functioning of the application in an environment. So what is important in a CD continuous delivery process is that deployment to the production environment, that is to the end user, is triggered manually by approved user. So this diagram that or this infographic which is on the screen clearly shows that CD process is a continuation of the CI process. It represents the chain of CD steps which are automatic for staging environments. Once staging environment is done, then after that you will go for acceptance tests through by many of the user acceptance tests. Then we'll have a manual. Then after the staging environment, a manual approval for production level deployment. So it also shows that the package is generated by CI continuous integration and is stored in a package manager, and that is the same package that is deployed in the different environment. That we have looked at CD continuous delivery. So let's look at continuous deployment practices. Continuous deployment is an extension of CD continuous delivery, but this time with a process that automates the entire CI CD pipeline from the moment the developer commits their code to deployment in production through all of the verification steps. So this practice continuous deployment is rarely implemented in enterprises because it requires a wide coverage of tests. Such as few examples of such tests are unit, functional, integration, performance, and so on and so on. List goes so on. So for the application, so these kind of tests are required. Wide coverage of these kind of tests are required for the application, and the successful execution of these tests is sufficient to validate the proper functioning of the application with all of these dependencies. But also automated deployment to a production environment without any approval action is also possible and is also used. So now let's look into the simulation of the implementation of the continuous deployment pipeline or the flow of continuous deployment pipeline. So the continuous deployment process must also take into account all the steps to restore the application in the event of a production problem. Continuous deployment can be implemented with the use of use with the use and implementation of feature toggle techniques or feature flags, which involves encapsulating the application's functionalities in features and activating its features on demand. So directly in production without having to redeploy the code of the application. So another technique that is widely used is to use a blue-green production infrastructure, which consists of two production environments, one blue and one green. So we first deploy to the blue environment, then to the green. So this will ensure that there is no downtime required at all. So the preceding diagram is almost the same as that of CD, but with the difference that it depicts the automated end-to-end deployment. You can see on the screen, but I haven't attach a flow, so I will simulate now. I just want to give you some important facts about CD, sorry, not CD, continuous deployment first, and then let's simulate the process. Let's simulate the process. As usual, it starts with the continuous integration. So our developers have committed and pushed their code through the SCM, source code managers, to the source code repository, that's GitHub, just for an example. Then after that, your Jenkins automation server got triggered, and then it has taken the source code from GitHub and it has built, and then it has run some service, some tests, and finally it has made and it has built a package. So now this package has been pushed to the, so one side the package should be pushed to the package manager, on other side, till whatever had happened, all the feedback has to go back to the developers, or else they can have a overall feedback. But for that we need to use a one more tool. In spite of sending the feedback here, of course you have to send the feedback here, and even after the production, every stage. It's not that only at the one stage, you have to send it every stage. Anyway, this is just a flow, a detailed diagram, and then practically building a CI/CD and continuous deployment pipelines we are going to do, even with the containers, containerization or Docker, in our forthcoming sessions. So that is the reason. Keep your excitement as high as possible, and with you just wait for the further forthcoming sessions. So here, so after the quick feedback, our package will be moved to the package manager, then automatically another server will be set up, that's a staging server, and then the package from the package manager will get back to the staging server, and then once all success it gets in staging server, then again it get back to the package manager, and from the package manager you'll get the package back into the acceptance tests server, and then the most important step comes. What is that? So CI/CD processes are therefore an essential part of DevOps culture, with the CI allowing teams to integrate and test the coherence of its code and to obtain quick feedback very regularly. So CD, continuous delivery, automatically delivers till the acceptance test stage on one or more staging environments, and hence offers the possibility to test the entire application until it's deployed in production. But whereas finally continuous deployment automates the deployment automates the deployment of the application from commit. Here is the commit. Here is the commit. From commit till the production of the environment. But here again, in the production of the environment, the package will be taken from the package manager. Here package manager or package management a repository, and from there the package will come to the production environment, and then that will be deployed. So the continuous deployment, what does it do? It automates the deployment of the application from commit here from the left side of the screen till to the production environment. So now let's move on to the most important component of DevOps, that is IaC, IAC. Okay, that is infrastructure as code. Infrastructure as code. So infrastructure as code is a practice that consists of writing the code of the resources that make up an infrastructure. So this practice began to take effect with the rise of DevOps culture and with the modernization of cloud infrastructure. Indeed, ops team or operations team that deploy infrastructure manually take time to deliver infrastructure changes due to inconsistent handling and the risk of errors. Also, with the modernization of the cloud and its scalability, the way an infrastructure is built requires a review of provisioning and change practices by adapting a more automated method. So IAC, you see on the screen, IAC is the process of writing the code of the provisioning and configuration steps of infrastructure components to automate its deployment in a repeatable and consistent manner. So that's what IAC is. Infrastructure as code. Infrastructure as code. So before we look at the use of IAC, we will see what are the benefits of this practice that provide. So the benefits of IAC are as follows. The first one is the standardization of infrastructure configuration reduces the risk of error. Two, the code that describes the infrastructure is versioned and controlled in a source code manager. The code is integrated into CI/CD pipelines, that's continuous integration and continuous delivery pipelines. Deployments that make infrastructure changes are faster and more efficient. So there is better management control and a reduction in infrastructure costs. So IAC infrastructure as code also brings benefits to a DevOps team by allowing ops to be more efficient on infrastructure improvement tasks rather than spending time on manual configuration, and by giving the developers the possibility to upgrade their infrastructure and make changes without having to ask for more ops resources. So IAC also allows the creation of self-service ephemeral environments that will give developers and testers more flexibility to test new features in isolation and independently of other environments. The languages and tools used to code the infrastructure can be different types. That is scripting and declarative types. So there are mainly two types, scripting type and declarative type. So let's begin with scripting types. So scripting types, these are scripts such as bash, PowerShell, or any other languages that use the different clients provided by the cloud providers. For example, you can script the provisioning of an Azure infrastructure with Azure CLI or Azure PowerShell. So let's take one example. So if you see the commands in this image that I have just put on the screen, so just populated up. So if you see that command, basically that command, so we are using Azure CLI. In that Azure CLI, if you give the command AZ, that's Azure main command, and then group subcommand, create subcommand. Then if you give the arguments and options and arguments, it will provision an Azure infrastructure. This is what a third type. It's a cloud based SDK, software development kits. So the problem with these languages and tools is that they require a lot of lines of code, because we need to manage the different states of manipulated resources, and it is necessary to write all of the steps of the creation or update of the desired infrastructure. However, these languages and tools can be very useful for tasks that automate repetitive actions to be performed on a list of resources, so or that require a complex processing with a certain logic to be performed on infrastructure, such as a script that automates the deletion of VMs, virtual machines that carry a certain tag. So now let's look into the second type, that is declarative type. So declarative types, these are languages in which it is sufficient to write the state of the desired system or infrastructure in the form of configuration and properties. So this is the case, for example, Terraform and Vagrant from HashiCorp, Ansible, the Azure ARM template, PowerShell, DSC, Puppet, Chef. So the user only has to write the final state of the desired infrastructure, and the tool takes care of applying it. So let's take one example. So the following is the Terraform code that allows you to define the desired configuration of Azure resource group. So you can see that's exactly on the screen in front of your eyes. So you just mentioned the resource. Anyway, we are going to do next in this module. The next part is Terraform only. So we will use the similar kind of declarative type script to provision instances in AWS. That we are going to do here, but we have taken Azure. So resource. So a resource name you write, and after that here you mention the resource name and location. Where do you want to put West Europe based on the region where you want to have, and then tags environment. So that's we are going to do. And uh, in this example, if you want to add or modify a tag, modify the modify the tag property in the preceding code, and Terraform will do the update itself. So next we will look into another example that allows you to install and restart nginx on a server using Ansible. So obviously Ansible is the another example. Ansible is the third part of this module. So on that also we are going to work. So similar kind of example we are going to take. So here Ansible uses AML declarative type. AML script. It uses AML format. Our So in this case, the first three dots represent this is a AML file. It's not necessary to include. It's not compulsory, but still it makes much sense to identify as a YAML file. Then hosts all tasks, install and check Nginx latest version, and then aptitude is the one. Apt is the repo we want to use, that package repo, and then name start Nginx service, name Nginx, and state started. So that's how we use IaC to provision and configure the instances and infrastructure. Instances and infrastructure. So now let's look into the IaC topology. So in a cloud infrastructure, IaC infrastructure as code is divided into several topologies. So the first one is the deployment and provisioning of the infrastructure. So here basically the deploying the applications and then provisioning a new, basically deploying and provisioning new types of infrastructure, as we have seen in our previous examples, in our previous slides. Those were the languages that we use, and those were the tools that we use to deploy and provision new infrastructure. Then the second one is the server configuration and templating. So here in the server configuration, what kind of tools are required, what services to be installed, and how the server to be maintained, and all these configuration, and how can we template the same server, how can you use that server, existing server as a template, and create more servers, and these kind of things will be done. And then the containerization. So the most important one, how can you run an application using containerization technology? How can you run using microservices? So that's what the containerization. And the fourth one is the configuration and deployment in Kubernetes. So nice. So you wanted to deploy your application using microservices. When you have a microservices, you will have a lot of containers. So how can you run all the containers together with a normal Docker and a normal Docker swarm and these kind of things? It's not possible to run a multi-level, multi-containers. So for that a reason, we need a container orchestration tool. Container orchestration tool. So that's what our Kubernetes is. let's look into the first component of the IaC topology. So that's the deployment and provisioning of the infrastructure. So provisioning is the act of instantiating the resources that make up the infrastructure. So they can be of the platform as a service. In short, we say PaaS, PaaS, and serverless resource types such as a web app, Azure function, so or event hub, but also the entire network part that is managed, such as VNets, subnets, routing tables, Azure firewalls. So all this terminology was discussed and practically demonstrated using AWS, Amazon Web Services. So kindly get back to the networking module. That's the third module of intuitive DevOps for you course, and watch that video to get the more understanding about subnets and routing tables. So for virtual machine resources, the provisioning step only creates or updates the VM cloud resource but not its content. So there are different provisioning tools such as Terraform. Basically, Terraform is provisional tool and it's automation tool also. So this is widely used for the cloud. Specifically, it is meant for the cloud related activities. So the ARM template, AWS cloud training, the Azure CLI, Azure PowerShell, and also Google Cloud Deployment Manager, or of course there are many more. So, but it is difficult to maintain. It's difficult to maintain and learn and use all together. So that's the reason. And obviously it's very difficult to mention all the things and do the practical exercises in all the tools and learn all the tools in this course. So it's obviously out of scope of this course. So that's the reason we will look at in detail. So the use of Terraform to provide an infrastructure, and the use of Ansible to configure the infrastructure. So now let's look into server configuration. So this step concerns the configuration of virtual machines, such as configuration of hardening directories, disk mounting, network network configuration, fire network configuration, nothing but firewall, proxy, and so on, and middleware installation. So there are different configuration tools such as Ansible, PowerShell, DSC, Chef, Puppet, and Salt Stack. Of course, there are many more, but in this course, we will look at in detail the use of Ansible to configure a virtual machine, and to optimize server provisioning and configuration times. It's also possible to create and use server models, also called images, so that contain all of the configuration, hardening, middleware, and so on of the server. So it will be during the provisioning of the server that we will indicate the template to use, and hence we will have in a few minutes a configured server ready to be used. So there are also many tools IaC tools for creating server templates. One of them, such as Emulator used by Netflix, or Harsey Core Packer. So here is an example of a Packer file code that creates an Ubuntu image with the package updates. So you can see the Packer file. So we have a uh, Packer topic also in fourth part of this fourth module. So there we will use a Packer file live, and then here let's try to understand. So you'll have a builders are mentioned here, and so this script creates a template image for the standard DS2V2 virtual machine based on Ubuntu OS. So the builders section you can see on top here. So type Azure ARM, and then OS type you are going for the Linux and canonical. That means it's Ubuntu server, and then 16.04 LTS, not the latest one. And then VM site standard DS2V2, and location where you want to launch this in West Europe. So managed image name sample Ubuntu. So additionally, a packer will update all packages during creation of the image with the apt-get. So here you can see provisioners execute command chmod. So all the permissions are given using chmod plus x, and after that you have path. Here you have two package management tools. Apt-get is one, apt-get update. So basically apt-get is the one that we are using here. So apt-get update command, and after this execution, packer deprovisions the image to delete all user information. So that you can see in the provisions section. So now let's look into immutable infrastructure with containers. Containerization consists of deploying applications in containers instead of deploying them in VMs, virtual machines. So today it's very clear that the container technology to be used is Docker, and that the configuration of a Docker image is also done in a code in a Docker file, capital D. So this file contains the declaration of the base image, which represents the bond to be used. So the installation of additional middleware to be installed on the image, only the files and binaries necessary for the application, and the network configuration of the ports. Unlike VMs, virtual machines, containers are set to be immutable. The configuration of a container cannot be modified during its execution. So containers are immutable. So example, we have deployed one application using containerization recently. So we need to add few more credentials to the application. So in that case, we had to stop the one service. We had stopped the one service, and then we have deployed the credentials to that, and then we have uh, we have recreated the image, and then we have rerun the image with the for the new container. So then the application again started running. This has happened just I think 2 weeks before only. So this again proves that containers are immutable. Immutable, what does immutable means? A container said to be immutable. The configuration of a container cannot be modified during its execution. Here is the following is the small simple example of a Docker file. So here is the example of Docker file. In this Docker image, we use a basic Ubuntu image that's from Ubuntu, that will get to the Docker hub, and it will fetch Ubuntu image, and then we want to then we want to run apt get update the apt get package management tool, and then we have apt get install nginx. We'll install the nginx, and after that entry point. So then finally, so once whenever the container runs, then execute the following commands: that user, go to the user has been nginx, there you'll find nginx binary file, and then you start that. That's what we are saying. And then expose this whole expose this container at port number 80. So now let's look into configuration and deployment in Kubernetes. Kubernetes is a container orchestrator. It's technology that most embodies IAC, infrastructure as code, in my opinion, because the way it deploys containers, the network architecture, such as load balancer, ports, and so on, and the volume management as well as the protection of sensitive information are described completely in the AML file, AML specifications files. So these are all called definition files, okay. So here is a simple example of a haml of a YAML definition file. So basically every uh, for every purpose, we have a different definition files in Kubernetes. So anyway, we are going to deploy a big microservices based application using Kubernetes after creating a Kubernetes cluster. So that we are going to do, that is our mega project. So in this, you can see the YAML file on your screen. So the name of the image to be deployed is nginx. So you come here, it's nginx, and it's open to the port 80. That's a container port 80, and the image name is nginx, and version 1.7.9, and the number of replicas that you want is 2. So here basically API version, the begins with the API version because it's all connected through API. All Kubernetes happens through API, and then kind, it's a deployment. There are different types of definition files. One is deployment, and other one is service, and there are plenty of. So then here you will have a metadata, and here spec replicas to app nginx, and here it's about the container. So here container will be built from image nginx 1.7.9. This will be directly fetched from the Docker hub, whereas if you have your own Docker file, you have to mention the Docker file location here. So and port where you want to expose this container, this specifically this pod. So the container which is built through this pod with because of the container which we built because of this one, it's in port 80. So now let's look into IAC best practices. So let's wrap up this part 1 of module 4 with this section, that the best practices of infra infrastructure as code. So infrastructure as code, like software development, requires the implementation of practices and processes that allow the evolution and maintenance of the infrastructure code. So among these practices are those of software development, as in these examples, have good principles of nomenclature, Do not overload the code with unnecessary comments. Use small functions. Implement error handling. So, but there are more specific practices that I think deserve more attention. One of them is everything must be automated in the code. When doing IAC, it is indeed necessary to code and automate all of the provisioning steps and not to leave manual steps out of code that distort the automation of the infrastructure and that can generate errors. And if necessary, do not hesitate to use several tools such as Terraform and Bash with the Azure CLI scripts. And the second best practice of IAC is the code must be in a source code manager. So the infrastructure code must also be in SCM to be versioned, tracked, merged, and restored, and hence have better visibility of the code between dev and ops. And the third one that we have in our pipeline of best practices is the infrastructure. The infrastructure code must be with the application code. So in some cases, this may be difficult, but if possible, it's much better to place the infrastructure code in the same repository as the application code. So this is to have better organization between developers and operations who will share the same workspace. And the fourth one is separation of roles and directories. It is good to separate the code from the infrastructure according to the role of the code. So you can create one directory for provisioning and one for configuring VMs and another directory, one directory for provisioning and for configuring VMs, and another directory that will contain the code for testing the integration of the complete infrastructure. So the fifth best practice that we have is integration into a CI/CD process. So one of the goals of IAC is to be able to automate the deployment of the infrastructure. So from the beginning of its implementation, it is necessary to set up a CI/CD process that will integrate the code. So test it and deploy it in different environments. So some tools such as TerraTest allow you to write tests on the infrastructure, and one of the best practices is to integrate CI/CD process of the infrastructure into the same pipeline as in the application. So next that we have is the code must be idempotent. The execution of the infrastructure development code must be idempotent, that is automatically executable at will. So this means that scripts must take into account the state of the infrastructure when running it and not generate an error if the resource to be created already exists, or if a resource to be deleted has already been deleted. So we will see that the declarative languages such as Terraform take on the aspect of idempotence natively. So the code of the infrastructure once fully automated, must allow the construction and complete destruction of the application infrastructure. So the seventh best practice that to be followed is to be used as documentation. The code of the infrastructure must be clear and must be able to serve as documentation. Indeed, infrastructure documentation takes a long time to be written, and in many cases, it is not updated as infrastructure evolves. And the eighth one is the code must be modular. In an infrastructure, the components very often have the same code. The only difference is the value of their properties. Also, these components are used several times in the company applications. So, companies applications, it's therefore important to optimize the writing times of code by factoring it with modules for roles and for Ansible, that will be called as functions. Another advantage of using modules is the ability to standardize resource nomenclature, resource nomenclature and compliance on the some properties. And the last but not the least best practice to be religiously followed is having a development environment. The problem with IAC is that it is difficult to test its infrastructure code under development in environments used for the integration and to test the application, because changing the infrastructure can have an impact. It's therefore important to have a development environments even for IAC that can be impacted or even destroyed by any time. So for local infrastructure tests, some tools simulate a local environment such as a Vagrant, basically Vagrant from IaC Corp. So if it is in your local machine, if you want to create a virtual machine, so Vagrant is more than enough. So you should use them to test the code script as much as possible. Of course, the full list of good practices is longer than the list that I have just shown you. So all methods and processes of software engineering practices are also applicable. So IAC is therefore like CI/CD processes, a key practice of DevOps culture that allows by writing code the deployment and configuration of an infrastructure. However, IAC can only be effective with the use of appropriate tools and the implementation of good practices. So, in this part of module 4, that DevOps and IAC, we saw that DevOps culture is a story of collaboration, processes and tools. Then we detailed the different steps of the CI/CD process and explained the difference between the continuous deployment, continuous delivery. Finally, the last part explained was how to use IAC with its best practices. So in the next part of module 4, we will start with the implementation of IAC and how to provision an infrastructure with Terraform. Then we will go to the Ansible and we'll see how to configure the infrastructure using Ansible. And finally, we use Packer to template this configuration and how to use Packer to create huge numbers of similar kind of servers.